can snoop or modify all traffic that LS sends. So really, when we're talking about host authentication and building a PKI, really the only question we're trying to answer is this key really belong to the person that I think I'm trying to talk to? That's essentially what this talk is about. So the first question you probably want to ask is, well, do I really need to care about this stuff? You know, people come up with hypothetical attacks all the time. And I would argue that, unfortunately, you do want to care about man-in-the-middle attacks. And in fact, you probably need to care about them a lot more now than you used to. There are a couple recent trends that increase man-in-the-middle attack vulnerability. The first is probably what's distracting you right now. That's a wireless network. Basically, so much of our connectivity these days is over wireless, but a shared wireless LAN lets you spoof ARP and DNS packets. For example, there's the recent ARP iframe worm. So really, when you're thinking about a man-in-the-middle attack, your mental model probably shouldn't be Mallory in a dark room typing on some keyboard, but it should really be a compromised laptop, for example, that's using man-in-the-middle attacks to snoop logins or to inject content into your web sessions. Another problem that's increasing man-in-the-middle attack vulnerability is growing prevalence of home routers and access points that have known vulnerabilities. These are the so-called farming attacks that you've probably read about on Yahoo or other, mainstream media that say farming, ooh. But I mean, the fact of the matter is that these devices have known vulnerabilities, and chances are, a lot of times when you connect, you're connecting at some coffee shop where the person actually in charge of running this access point, their main responsibility is making good lattes, not running a secure network. So that's another reason you might be worried about man-in-the-middle attacks. And then finally, you're probably all sick of hearing about the Kaminsky DNS attacks. But that was yet another attack vector that we've seen come out recently that allows someone to become a Mallory in the middle. So those of you that have been kind of following security trends should also be interested in noting that a lot of these attacks, these man-in-the-middle attacks, have become increasingly automated and profit-driven, which might set up a red flag that we should be worried about them becoming a bigger problem in the future. So, man-in-the-middle attacks are nothing new. In fact, they've been around for, as long as the internet has been around. People have proposed solutions. Well, there's two major solutions that you've both used, and maybe you both use every day. The first is a public key infrastructure. This is where a certificate authority like VeriSign takes some of your cache and gives you a certificate, saying that, you do own this domain name. The second mechanism is prayer. Now that may sound a little weird, but if you've ever just typed yes at an SSH prompt or clicked OK to accept a self-signed cert, really, if you think about it, you're trusting a bit of your internet security to some higher authority. So what exactly do I mean by prayer? Well, first of all, in academia, we can never get away with calling something prayer authentication. So we're going to refer to this prayer mechanism as SSH-style authentication. So what exactly do we mean? Well, SSH-style authentication, the basic steps go something like this. First, when you first connect to a new server, you basically pray that there's no adversary on the first connection. Then you cache the key. You keep connecting, and everything's fine as long as the key changes. But if the key ever changes, you panic. You don't know what to do. So what do? Well, a lot of us are guilty of probably praying again and just connecting anyway, right? Well, why would anyone use prayer? This sounds silly. We have this PKI thing. We figured this out. Move on. Well, the fact of the matter is, PKIs, unlike a PKI, using SSH is cheap and simple, right? So they got something right there. They just weren't so strong on the security parts. Think about what a pain a PKI can be. So when I say a PKI, I mean a secure PKI. We'll get, maybe we can debate that later, whether all PKIs today are actually secure. But a secure PKI is often costly because the certificate authority has to manually verify that you are the person you say you are before it can grant you a certificate. Plus, I as a server administrator have to manually generate a cert, email the certificate signing request into the certificate authority, get the response back, and manually install it. And I have to do this for each one of my servers every year. And this admin cost also is another reason traditional PKIs are not simple to use. So if you think about it, when was the last time you had any of these concerns about SSH? Right? SSH is this great model. You just plug it in, and it starts working. right? And I think this is one of the big reasons we saw SSH just very quickly and ubiquitously replace the completely insecure telnet. So what we did with Perspectives was kind of look at this model and say, there are a lot of things about this very simple SSH-style authentication that we'd like to keep. Basically, the simplicity of administrating the servers and the low cost of verifying the identity of the server owner. But of course, we need to improve the attack resistance. So that's kind of the key principles that are driving our design with Perspective. So here's the 10,000-foot view in pictures of how Perspectives works. So we have Bob.com, and Bob pops up onto the internet at some point. He doesn't, in our scenario, he doesn't contact a certificate authority at all. He just generates a key just like your SSH server would. So Perspectives uses a set of nodes scattered across the internet that we refer to as network notaries. So once the network notaries learn about Bob, they periodically mimic clients and just ping Bob with requests. They connect to Bob, they say, hey Bob, what's your public key? Bob responds. And they build up a history of the of the keys used by Bob.com. Now note, Bob.com doesn't actually have to know that these are network notaries connecting, because these network notaries just look like normal clients to Bob.com. So Bob.com doesn't need to be modified at all. So let's return to our original example of Alice connecting to Bob.com. So Alice, again, is going to send a hello to Bob.com, and Bob is going to send back the key. Now, in the future, we'll refer to this key that Alice received directly from the untrusted network, which she hopes is from Bob.com, as the offered key. And of course, the question she again wants to answer is this really Bob.com's key? Well, in Perspectives, what Alice can do is query the notaries. And this is actually secure communication. We'll go over the details later. But Alice gets back a set of keys, or key histories, from each of the notaries. And we're going to call these the notary observations. And then what Alice basically does is runs a client policy, which is just a fancy name for she does a kind of a basic sanity and consistency check. Does the offered key I received make sense in terms of the notary observations? And if they are consistent, she will accept and use the key to connect to Bob.com. If they're inconsistent, she'll determine that there's been an attack or something suspicious. She'll reject the key and abort the connection. So what kind of protection can this system actually give you? Well, we talk about the protection that Perspectives offers in terms of two types of resistance. The first is spatial resistance. So network notaries probe from all over the internet, and so they give you multiple vantage points. Oftentimes attackers are localized in a particular area. For example, your wireless network, or they compromised a few DNS servers. That way, for weak attackers that are localized, network notaries provide these multiple vantage points that can easily let Alice detect that this is an attack. Well, what about really powerful network adversaries? For that, Perspectives offers something called temporal resistant. That is, the history of the keys over time can actually let Alice potentially detect an attack, even if malware is on all paths between all notaries and Bob. So here we see that during normal network circumstances, the notaries are probing and building up a key history of Bob's legitimate key. At some point, malware gets on all network paths between Alice, all of the notaries, and Bob. And so we see even the notaries report incorrect results, right? Because the notaries don't know what's right or wrong. They just know what key they're getting when they're trying to connect to Bob.com. And so the point here is that Alice can look at this key history, notice that there was a sudden change, and be suspicious of that, and potentially reject the key. So what we see here is with temporal redundancy and spatial redundancy, we get a model that's not bulletproof, but is significantly better than the SSH model. So by now, you probably have lots of practical questions buzzing around your head, like, hey, who runs these notary things? Or what exactly are the notaries doing when they contact the clients? When they contact the servers, and most importantly, how do clients get this data from the notaries and actually decide to accept or reject a key? So now we're going to take a look at some of these questions. So first off, who's going to run these network notaries? Well, the short answer is I don't know. That's one of the reasons I'm here talking to you guys. We think there are a couple models. First, it could be someone with money and with kind of the will to help the internet, someone like a Mozilla or a Google or an EFF, basically says, listen, buying these network notary servers, hardware super cheap, bandwidth super cheap, let's just make this happen. Another possibility, and one of the main reasons I'm here actually, is we think there might be a useful community deployment model in which ISPs, universities, web hosting companies, etc., each volunteer to run a single network notary node. Now, this kind of a model where everyone pitches in a little bit is actually not without precedent. Many of you are probably familiar with the network of publicly available traceroute and looking glass servers that exist for diagnosing networking problems. In addition, there's Planet Lab, or testbeds like Planet Lab and Ron have actually been built by universities and ISPs donating 1 or 2 machines at a time. Now, while we don't really get into the details, I don't really have time to get into the details during this talk, kind of a fundamental part of the perspectives design and security analysis assumes that some notaries at any given point in time may be malicious or compromised. And so we really did design with this kind of community deployment model in mind. Okay, so when we're talking about these network notaries, how many are we thinking? Well, the short answer is we don't totally know. In fact, I have a strong disagreement with my advisors about this, but I would imagine somewhere in the realm of 10 to 30 global vantage points would be what we want. Some of these servers may actually want, have multiple servers in a particular location for redundancy or load balancing, depending on how many people are using the system. So what else is necessary to make this system happen? Well, any client software that is going to use this needs to be shipped with a master key. And this master key basically bootstraps the trust. And so daily, the clients will contact the central notary authority. They'll download a new list and say what notaries are part of the notary system and what are their public keys. And we'll need this information in a couple steps in order to securely connect to the notaries. So the next question we want to look at is what exactly happens within a particular notary? Well, you can think of the notary as logically being broken into 2 different components. The first component is the probing modules, and the second is the notary database. Probing modules are really just a fancy name for software that mimics the behavior of a client. Basically, this is protocol-specific modules that can connect to the server and grab public keys and then disconnect. And so on a daily basis, the network notary basically looks at every service it knows about in its database, sends a query to it, acts like a client. Once the SSL session or the SSH session has exchanged the public key, they disconnect, and they update the results of the database. So what's exactly in this database? Well, let's zero in on a particular record for an imaginary domain called shop.com. So each record in this database is identified by a DNS name, a port, and the protocol used to probe it. And so each of these records will contain 1 or more keys. Here we represent them as MD5 sums. And each key will be associated with 1 or more time spans. This isn't rocket science. All we're doing is just basically recording the keys we've seen at a different time, ever since we've been probing this host. And so there is one more thing we add, which is a signature, which is updated each time the notary probes. And this signature is created using the notary's private key. So let's look at an example now where a client, like Firefox, wants to use notary data. Well, we need to extend the client with a slight amount of extra code in order to do this querying of the notaries and running the client policy. And so this notary client code will basically, when Firefox connects to a domain, the notary client code will generate a notary request with the protocol, the DNS name, and the port, and send it to the notary. Now these queries are done over DNS. So these are UDP datagrams that are similar to DNS. We're actually looking at a possibility of running this entire system over DNS. We'd be interested in your feedback. But so when the client gets this result back, the first thing it does is verify the signature. This is very important because if an attacker is launching a man-in-the-middle attack and could just spoof notary responses, there'd be no point into designing the system at all. So finally, the big question. What do clients do to determine whether they want to accept or reject a key? Well, as we mentioned in the overview slide, essentially what they want to do is check for spatial and temporal consistency. Now, there are a bunch of different approaches you could imagine to this, but we'll look at just kind of two primary approaches that you might use. The first is manual key policies. These are what you might do if you have some power users like you or me, for example, that are very familiar with security and you know all the details and you just want to be told more information so you know whether it's safe to accept or reject this key. So a notary client might tell you something like, 6 of 6 notaries have consistently seen the offered key for the past 200 days. This personally would make me feel pretty good about accepting this key. Now there's some other things that I might see that would actually make me pretty worried, such as 4 of 6 notaries currently see a different key. That would lead me to believe that there might be an attack. Now just for a moment, compare this to what SSH tells you right now. It says, hey, I don't have this key cached. Do you want to trust it? Right? So you can start to see how having this extra notary data really lets you determine whether there's likely to be a real attack or whether this is just a spurious warning. So essentially what a power user is doing here is looking at the notary data and saying, is there enough evidence that the offered key is correct, that it passes some kind of consistency threshold? Well, thankfully, this kind of same consistency threshold logic can actually be automated. Because let's be honest, most Firefox users have no idea what a man-in-the-middle attack is, or even what a public key is. So being able to automate these policies is very valuable. And so what Perspectives actually lets you do is it allows the user to make a high-level decision, such as, I prefer very, very strong security, even if it means I'm going to disconnect in some cases when the key is valid. Or they can make the choice where I prefer high availability, even if it means a very powerful attacker might be able to trick me. So let's take a look at 2 example policies that could be converted into automated thresholds. So first of all, you could configure your Firefox to say that anytime you get a key that's self-signed, unless 100% of the notaries have seen the same key for the past 3 days, I want to reject it. Well, what does this policy really say? It really says that I want very high security. If anything seems even remotely suspicious, I want to be super safe and disconnect. Of course, some users might not want that. Another policy that's a high availability policy would say that, well, really all I care about is that at least 50% of the notaries currently see the offered key, and I don't really care about any of the history. Really, this person is saying, I really value my ability to connect to the server. I almost never want to be able to not be able to connect to the server. And I really just want protection against very simple attacks. Like, I want to make sure someone's not on my local Wi-Fi network. So we see that even when we automate these key policies, users can still make high-level choices, whether they want to prefer security or availability. And of course, I'm glossing over lots and lots of details here, which you can all read about in our paper. And we also tie these, the different thresholds and the different threshold parameters to our security analysis. So if any of this is remotely interesting, I'd encourage you to check out the website and check out the paper. Okay, so what's the story so far? Well, we've already said that the traditional PKI model is costly and kind of a pain in the butt to use. Well, what Perspectives does is that it retains the good parts of SSH-style authentication. That is, it's low cost because probes are super cheap, bandwidth is cheap. And it's super simple because server administrators don't have to do anything special. They don't have to manually install certs or communicate with the certificate authority. But what we've done is with spatial and temporal redundancy, we've greatly improved the attack resistance of the standard SSH model. So what we're left with is something that's not bulletproof, but might be useful, might provide a useful security trade-off for some non-security critical websites. So now what I'd like to do is look at 3 potential uses for Perspectives in the real world. The first is something we've actually already been using Perspectives to do, which is to strengthen existing uses of SSH and SSL against attacks. As many of you are probably aware, Firefox and Internet Explorer recently made changes that make self-signed certificates essentially security errors. And it's a real pain in the butt to use these web browsers with self-signed certs now. So we've actually written a Firefox extension that automatically queries the notaries and will override these error pages if the notary results provide strong evidence that there's no attacks. We've actually had over 10,000 people download this, and so apparently they find it useful or at least interesting. So this is one place where I think perspectives can definitely have an impact. There are a couple more of these that might be a little more contentious, but what the hell, I'll go for it. So the second is that perspectives might be an attractive alternative to the low-end CA signed certificate market that exists today. So what do I mean by the low-end cert market? Well, for those of you that have been paying a lot of attention to PKIs, and well, maybe that's just me because I'm a big dork, but anyway, what you can see is that the HTTPS certificate market is bifurcating into two different compartments. Basically, there are secure but expensive certs. These are high-end certs, granted by VeriSign. You may have heard the terminology extended validation. These are certs that cost serious money and have manual processes that verify you are the person requesting the cert. The other end is this low-end market that I'm really talking about. Low-end certs are, from people like GoDaddy. They say, hey, give us $10 or $20 and we'll give you a cert. What we'll do basically is we'll look in whois, we'll find out what the email address associated with this domain is. We'll send it an email. If you can send an email back, that's good enough for us, right? So while these are super cheap, they're also less secure. And so why do I think perspectives might be good for this market? Well, compared to these low-end certs, I would argue that perspectives actually offers comparable security. Now, why is that? Well, if you think about what it takes for an attacker to fool perspectives, you need an attacker that can basically take control of a large number of paths in the internet to bob.com or whatever destination you're talking about. Well, an attacker with equivalent power could very likely spoof these verification emails sent by a low-end CA. And in fact, well, with perspectives, there's this notion of temporal resistance, which is that you have to be able to sustain your attack for a long time in order to fool all of the notaries. There's no such requirement with a lot of these low-end certs and their email verifications. I could just hijack something, request a cert, right, spoof the email, and then quit my hijack, and I have a valid cert for that domain. So there are other reasons I think perspectives is actually attractive too. So if it's comparable security, I argue that it's much more convenient for server admins to use. Remember that with SSH-style authentication, the server admin doesn't need to manually request or install a certificate. The server can just auto-generate a key and start using that because the network notaries will start probing them. Also, this is a bit of a detail, but those of you that have ever tried to use SSL with a virtual hosting solution that has shared IP, that share multiple services on a single IP address, know that it doesn't work. Well, actually, with perspectives, this would work, because perspectives treats all self-signed certs and any cert basically just as a public key. And so it could bind the same public key to whatever domain name you have, even if you're sharing an IP address. So not only is it more convenient for server admins, but I argue there are benefits to having a solution that's based on freely available data. First, because this data is generated by these network notaries, there's no transaction that ever happens between the servers, necessarily, and the network notary. And we argue that really there's no reason the server owners would have to pay anything for this service. In fact, it's so dirt cheap to run these network notaries that the thought of, I'm running a notary right now that probes, I don't know, maybe like 10K different host names. And it's not even, it's a small fraction of a percent on a box that we're running right now. Bandwidth is cheap, hardware is cheap. And another advantage of being based on freely available data is that clients can actually make individualized security trade-offs. If you think of what a CA signed cert right now says is, if the person has a CA signed cert, that means that key is valid. But what a client can do with notary data is say, actually, I'm a little more worried about this website. I want to be pickier about what keys I accept for this website. Right? So if we think back to our example, they could apply a different client policy. Right? They could say, I'm going to demand very high consistency for my banking website. But, this website I log into for my school, well, I'm going to apply a different client policy there. And that's something you can't do with the current CA model because it's just not flexible and it's not based on publicly available data. So The third possible use of perspectives is that it could provide an additional layer on top of the existing root-signed SSL certificate model. What do I mean by that? Well, I don't know how many of you have ever opened your browser and actually looked at how many certificate authorities are trusted by it. But the number is pretty high. 30 plus is a pretty conservative estimate. I can't count much higher than that, so, you know. I just quit at 30. But the point is that if any of these certificate authorities are tricked into granting a invalid certificate, basically everyone, you know, they could fool any client. And heaven forbid that their root key would be exposed, in which case someone could spoof any website. Well, how might perspectives be able to help with this? Well, remember, perspectives uses the kind of the current state of the network to bind public keys to DNS addresses. And so even if someone presents you with a root signed certificate to, you know, bank.com, and you query the notaries, you could see from the notary data that bank.com was not seen using that certificate from any of the notaries. And thus, you could detect this inconsistency and reject the key even if it was actually signed by a trusted CA. There are a bunch of other interesting possibilities, I think, that basically have to do with using the, the notary data, the data collected by notaries, to proactively detect attacks. For example, imagine that the bank, you know, or a bank, or Bob.com, for example, could actually monitor the notaries himself and say, hey, why is this different key suddenly popping up? Maybe I should look into that. Maybe I should report an attack to that ISP. Right? So I think there are a bunch of different interesting ways we can also use this probing data to detect attacks, even if it's not the primary data that is being used to authenticate a key. Okay, so I just threw a lot of information at you. So I'm about to wrap up, but I want to give a pitch for the currently running network notary deployment that we have right now. Basically, there's something called the RON testbed, which is an academic testbed, and we have 4 or 5 network notaries running on it. And how it basically works is if you contact the network notaries and they've never heard of the service you contacted them about, they will probe on demand and give you results, and then they'll keep probing that service. So we have 3 types of existing clients that you can check out on the website, play with, give me feedback. I'd love to hear your thoughts. The first is a modified version of OpenSSH. This kind of follows the power user model we were talking about before, where anytime the key you get isn't the one you have cached locally, that is either the first time you connect to a server or if there's a key change, this modified version of OpenSSH will contact the notaries and present you with the notary data. This lets you make a better security decision. We also have the Firefox 3 extension that I mentioned earlier, that in this case, if it ever gets a self-signed certificate that it can't validate, what it does is it contacts the notary, looks at the results, and then based on your personal settings, whether you chose high availability or high security, it may choose to override the security error. Of course, you can also configure it to not automatically override the security error if you just want to play with it and see how it works. And finally, if you're allergic to installing software written by me, you can just use the web to query this. On our main website, we have a kind of, you know, simple PHP page that you can use to enter in a DNS name, a port, and a protocol, and you can see the notary results for that site. So if you're interested in maybe running a network notary server, here are some very quick stats that you should know about. Well, running the notary code on a modern server, that is a 4-core, 2-gig machine with tons of RAM, basically that machine can do almost 17 million unique probes per day. Or it can handle 25K notary queries per second. So these are pretty big numbers. So we think for a reasonable deployment, you could just have a single server running, doing both the probing and the query handling, which is actually what we do right now. If you're thinking of using that old workstation you have, sitting under your desk, here are some other numbers. The probe numbers are lower, but still, 2 million probes a day is, non-trivial. There aren't even that many websites that are running HTTPS. So, there are more than 2 million, but, it's in the right range. And the queries per second is actually comparable to the modern server. So the good news is this code is highly unoptimized. That's code for its research code, and we got it working, but I didn't optimize it. So I actually think there's probably room for about a 3 or 4x improvement in the probing numbers. So and also, as we look toward the future, I think we're going to scale very well with hardware trends, because if you think about these operations, they're all trivially parallelizable. That is, the more cores you have, you get that much of an increase. That's one of the reasons why you see such a jump with the modern server versus the old single-core workstation. So with that, I should note that all of this code is, of course, open source. We have source and binaries available on the website, as well as the web demo. Here's a link to the paper. If you have any feedback or flames, or you're interested in helping out, there's my email. And with that, I will take any questions. I didn't know there was anyone left in here after I gave. No.
So, Warren Kamari, Google. Is there a way for Bob to roll his key over without tripping the temporal?
That's a great question. And in fact, in the paper we don't mention anything, but we've actually have been thinking about how you would work that into the design. And the unfortunate thing is we think it actually would require changes to the server, and basically letting the server kind of put 2 keys out there at the same time, and letting one build up a history. And then once that history is built up sufficiently, you could then start using the second key. That's a very good question. Any other questions? All right, thank you very much.